This is Math 236, Calculus for Business and Social Science. Today we will learn the Chapter 3. The topic of Chapter 3 is differentiation. We will separate into two parts. First part we call Chapter 3a. A part, it's computation, calculation of differentiation. Second part we call Chapter 3b. It's applications. Apply the formula in the social science and the business. First of all, today's 3A parts, we have several formula we need to memorize. Now, the following here, this is the examples of Chapter 3A part for homework question. Example for Chapter 3A homework. No, you don't need to use calculator in this 3A part. Show all your works. Please provide the following rules of derivative. Those are rules. Derivative, sometimes you can call differentiation. Derivative, differentiation. So those are the rules for differentiation or derivatives. Now, first question, derivative of a constant. So if a function is a constant, like f of x equal c, c is a constant. C is a constant. And this kind of function we call constant function. Derivative of a constant is 0. And you probably will ask why the derivative of a constant is 0. How do you know it is 0? Because constant, for example, if f of x equals c. Now, what is f of x? Which is we call y. So y equals c. When we draw the graph, it's for example, like y equals 3. 1, 2, 3. And this horizontal line, y equals 3. Derivative of this line, the graph is a line, horizontal line. Y equal a constant, the graph is y equals c is a horizontal line. Slope of horizontal line is what? It's 3 minus 3 over, for example, like here 1, here's 2, over 2 minus 1. This point is 2, 3. This point is 1, 3. So y change, 3 minus 3 over x change, 2 minus 1, which is 0 over 1, which is 0. So slope is always 0 because y always 3 minus 3. So always 3 minus 3 over f of x plus h minus f of x over h, limit h approach to 0. This is the first derivative, f prime of x. Now, no matter what kind of x plus h, plug in, function value is c. No matter what kind of x, plug in, function value always c over h approach to 0. So it's equal to limit h approach 0. C minus c is 0. 0 over h is limit of 0 when h approach to 0. So limit always 0. That's why the first constant term take derivative is constant take derivative is 0, constant function. And power rule is x to the power n take derivative is n go from to n x to the power n minus 1. And why is this? Just use this definition, f of x plus h minus f of x over h, limit h approach to 0. That's f prime of x. Like this, you can prove it. F prime of x equal limit h approach to 0. Now this function is f of x equal x to the power n. So x plus h is x plus h to the power n minus f of x. F of x is x to the power n over h. And then this one, then we have to prove it. Use this one, you are able to prove it. First of all, you can prove when 2, and then prove 3. Use mathematical induction. First of all, we prove when n equal 2, and then n equals 3. And by the induction, mathematical induction, we can say for all the n, the rule is n times x to the power n minus 1. So the rest of it, they all use the derivative. First derivative, this one, definition to prove it. To prove all the rules. So second one we call power rule. The third one we call the scalar. C is a scalar times a function, f of x. The rule is just the C scalar go from, and then take derivative. F take derivative. This f take derivative. Dx f of x take derivative. We can use this simple notation, f prime of x, to represent. So the C constant still constant. F of x take derivative. It's f prime of x. And then next is the sum and the difference. Next is the sum difference. The next is a product rule. The next is a quotient rule. So we have sum, difference, plus, minus, and product is a multiplication, and the quotient is a division rule. The two function f of x, f function and the g function take derivative is equal to each function take derivative and the sum of it. So the sum of the two function take derivative is the sum of the two function take derivative. And the subtraction is difference. The difference of the two function take derivative is equal to the difference of derivative of each functions. And the product rule is this. It's f times g. F function times g function take derivative is equal f prime. I simply write on this. Simplify right is like this. F times g product take derivative is equal f prime times g plus f times g prime. Like this, simplify right. Cf take derivative prime is equal cf prime. F plus g prime is equal f prime plus g prime. Then quotient rule. After take derivative is this one. We simply write like this. F over g prime is equal g square, g function square, and that's denominator. Numerator is f prime times g minus f times g prime. Simplify, write this. That's easier to memorize. Then the chain rule. Chain rule is outer function take derivative g prime, then times the inner rule take derivative f prime. And the general power rule is n to the from and f to the power n minus 1, just like this power rule. Here is x. N go from x to the power n minus 1 times by inner function f of x take derivative, which is f prime of x. Like this one, n go from n minus 1, x to the power n minus 1, x take derivative is 1. Use x take derivative is 1. So it's times by 1, which is this. So this power rule. So we have 8 of it. Now, the following, we are going to practice those rules. Use those rules to do. Now, first question, f of x equal -3. -3 is a constant. This is constant function. Take derivative. Derivative is 0. And second question, f of x equal x to the power 5. Take derivative. It's this 5 go from and x to the power n minus 1. 5 minus 1, so it's 4. So 5x to the power 4. Next one, power rule. 3.1 go to the from, and x to the power 3.1 minus 1, which is 2.1. So 3.1 times x to the power 2.1. Next one, number 4. So, and this 3 is a scalar. Take derivative, is 3 still there. X squared, use power rule. So 2 go from at x to the power 2 minus 1. And so this 2 times 3 get 6. So you can directly do 2 times 3 get 6. And then 2 minus 1 get x to the power 1. Next one, this also pi is a scalar. So pi is still there. And this is r is variable. R is f of r in terms of r. R is variable, just like x. Then 2 go from, then 2 minus 1. So 2 times pi. So it's 2 times pi is 2 pi. And 2 minus 1 is r to the power 1. And this also have a scalar. And if this function take derivative, 9 is still there. And 1/3 go from, then 1/3 minus 1 is exponent. And so 1/3 times 9 gets 3. And 1/3 minus 1. 1/3 minus 1. So since 1 is 3 over 3, and get the same denominator is 3, numerator 1 minus 3, get -2 over 3. And the negative exponent, and you use negative exponent rule, bring down to the denominator. Exponent, negative exponent rule is x to the power negative n equals 1 over x to the power n. This is negative exponent rule. Now, -2 over 3 and bring down to the denominator. Negative change to positive. So it's become 1 over 2 over 3. And 3 is still on the numerator, and just this x -2 over 3 become 1 over x to the power 2 over 3. So it's become on the denominator. And the question 7 is 3 square root of x. Square root of x, you will use the radical change to exponent rule. What is the radical change exponent rule? Is x to the power m nth root equal to x to the power m over n. That's from radical change exponent. So square root 3 square root of x. Square root of x, x to the power 1. Square root is 2. This square root of x means square root of x to the power 1. Square root, this 2 is, we don't write out, is 2. So change to exponential form is 1 over 2. 1 over 2. So become exponential form x to the power 1 over 2. And then take derivative. So 1 over 2 times 3. 1 over 2 times 3 is 3 over 2. X to the power 1 over 2 minus 1. 1 over 2 minus 1. 1 over 2 minus 1 is equal 1 over 2. 1 is 1 over 1 times 2 both sides. It's become 2 over 2. 2 divided by 2 is 1. And then same denominator 2, numerator subtraction. 1 minus 2. 1 minus 2 is -1 over 2. So it's x to the power negative 1 over 2. Now, since it is a negative exponent, you bring down to the denominator 3 times x to the power negative 1 over 2. Negative 1 over 2, bring down to the denominator, become x to the power positive 1 over 2. And this 2 on the denominator. And this x to the power 1 over 2 change to back to radical form is the square root of x. We have to change back to radical form because original here is the square root of x. Then next one, 7x to the power negative 12. Also, this negative 12 times by 7 is a negative 84. Then negative 12 minus 1. Negative 12 minus 1 is a negative 12 add negative 1. So it's become negative 13. And bring this negative exponent down to the denominator, become positive 13. And the negative 84 still on numerator. And this, first of all, this 5x squared have a scalar, still 5, and use power rule to go from and x to the power 2 minus 1. And use the difference and the sum rule. This is 3 function. One is the subtraction, one is the addition. So use each, if a difference and the sum, then each function take derivative. So this first term take derivative, get 10x, 5 times 2, and 2 minus 1 is x to the power 1. Second term take derivative is a negative 3, and 1, and 1 times by 3 is a 3, and 1 minus 1 is x to the power 0. X to the power 0 is 1, equal 1. So it's a 3, it's minus 3. And 7 is a constant term, take derivative is 0. And the 3 term, one is minus, one is plus, and put together. So separate, take derivative, and then do subtraction and addition. So quick way is 5 times 2, get 10. 2 minus 1, get x to the power 1. And the negative 3x take derivative is a negative 3. And the 7 take derivative is 0. Next one, this is also 3 go from times negative, get negative 3. And the x to the power 3 minus 1, which is a negative 3x squared. Then 2x squared, 2 go from, 2 times 2 is 4. And 2 minus 1 is 1, so it's 4x to the power 1. And constant term, negative 6, take derivative, is 0. And question 11, this is 2 go from times the 0.03, get 0.06. 2 minus 1, so it's x to the power 1. Then minus, and 0.4 times 1 is 0.4. X to the power 1 minus 1. Which is x to the power 0, and that's equal 1. And 10 take derivative is 0. Constant term take derivative is 0. So apply those rules. You can get the answer. And so this is practice those rules. Practice the rules. Now next one is question this. First of all, you have to divide it. Each term divided by x. Each term divided by x. Then 2x cubed, x cancel x, get 2x squared. For x squared, cancel x, get 4x plus 3 over x, and switch up to the numerator. Then become x to the power 1, become x to the power negative 1. X to the power negative 1, switch down to the denominator, become 1 over x, and switch up, get x to the power negative 1. Then each term take derivative. 2 times 2, it's 4. 2 minus 1 is x to the power 1. Negative 4 times 1, it's a negative 4. And 1 minus 1 is x to the power 0, it's 1. So it's negative 4 times 1 is negative 4. Minus 3 times negative 1 is minus 3. X to the power negative 1 minus 1, which is a negative 2. X to the power negative 2, bring down to the denominator. 3 still 3, negative 2. This bring down to the denominator become x to the power positive 2 and 4x minus 4. So next one, it's 4 times 4 is 16. 4 minus 1 is x cubed. 3 times 5 over 2. 3 times 5 is 15 over 2. X to the power 5 over 2 minus 1. 5 over 2 minus 1. 5 over 2 minus 1 is 5 over 2 minus 1 is equal 5 over 2. 1 is 1 over 1 times 2 both sides. And get same denominator is 2. The numerator 5 minus 2 gets 3 over 2. So we got 3 over 2. X to the power 3 over 2. And then constant term 2 take derivative is 0. Next one, 5 times negative 1 is negative 5. Negative 1 minus 1 get negative 2. Negative 1 minus 1 is negative 1. Add negative 1 get negative 2. Plus 4 times negative 2 is negative 8. So plus negative 8, so become minus 8. X to the power negative 2 minus 1 is negative 2. Add negative 1 get negative 3. Then bring down to the denominator. X to the power negative 2 bring down to the denominator. Negative 5 still on numerator. And then change to positive 2. Then negative 8 minus 8. X to the power negative 3 bring down to the denominator. Become positive 3. X to the power positive 3. Question 15. And this one use product rule because this is two function. 2x is one function. Another function, x squared plus 1. And product rule is a function f times g take derivative is equal first function take the f prime times g plus f times g prime. You can use your own way to memorize. I use this way to this order. You can use your orders. I use this order memorize. So first of all, f function 2x is f function. Take first function, take derivative, get 2. Second function, do not take derivative, is still x times still x squared plus 1. Plus first function, do not take derivative, is 2x. And second function take derivative, x squared plus 1 take derivative. X squared take derivative is 2x. 1 take derivative is 0. So x squared plus 1 take derivative is 2x. And then distributive in 2x squared plus 2 times 1, 2. Remove the parentheses. 2 times 2 is 4. 4. X times x is x squared. Then combine like term. 2x squared and 4x. 2 add 4 is 6x squared plus 2. And next one also, 2 function. This first function, this second function, take the product. Use product rule. Product rule. So product rule is first function take derivative. T minus 1 take derivative is 1. Because t to the power 1 go from, it's 1. Then t to the power 1 minus 1 is t to the power 0. It's 1. 1 times 1 is still 1. And second function, do not take derivative. And times, put the parentheses, 2t plus 1. Plus, the first function, do not take derivative, is t minus 1. Put the parentheses. Second function, 2t plus 1, take derivative. 2t take derivative is 2 times 1 is 2. And then t to the power 1 minus 1. 1 minus 1 is 0. So, and t to the power 0 is 1. So 2 times 1 is 2. And first function do not take derivative, still t minus 1. And then remove the parentheses. 2t plus 1 times 1 is still 2t plus 1. And this 2 distributive in. And get 2t minus 2. Combine like term. 2t add 2t. It's 4t. And 1 add 1 minus 2. And get minus 1. So it's 40 minus 1. And next one, it's also a product rule because it's two function tying together. Product rule. So first function take derivative. 3x plus 1, take derivative is 3. Second function copy down, parenthesis x squared minus 2. Add. First function do not take derivative is 3x plus 1. Second function take derivative. X squared take derivative is 2, go from, is 2. X to the power 2 minus 1 is x to the power 1. Add, negative 2 take derivative is 0. So this is 2x. Then distributive in 3x squared minus 3 times 2 is 6 plus 2x times 3x is 6. 2 times 3 is 6. X times x, x squared. 2x times 1 is 2x. Combine like term. 3x squared add 6x squared is 9x squared plus 2x minus 6. And that's final answer. Then next one, question 18. Use quotient rule. And what is quotient rule? It's first function f over g. Take derivative is equals to g squared f prime times g minus f times g prime. This quotient rule. So divided, numerate first function and divided by second function denominator. Divide equal to, take derivative, equal to denominator square, g square, 2x plus 1 square. And the numerator is first function, numerator, take derivative, 2x minus 1, take derivative is 2, times second function, denominator, do not take derivative, is 2x minus 1. Then minus first function, do not numerate, do not take derivative, 2x minus 1. Second function, denominator, 2x plus 1, take derivative is 2, times by 2. And then distributive in. 2 times 2x is 4x. And then minus 2 times 2x is 4x. Negative times negative, distributive in. Remove the parentheses, and you change to plus. And 2 times 1 is 2. Combine like term. 4x minus 4x is 0. And 2 add 2. 2 add 2, it's 4 over denominator. And this also, quotient rule. Quotient rule, take derivative. This is in terms of s. Variable is s. So denominator s plus 1, quantity square. Then numerator take derivative. S squared minus 1 take derivative to the s is 2s times denominator s plus 1 minus numerator do not take derivative is s squared minus 4. Denominator take derivative, s take derivative, it's 1. And 1 take derivative is 0. So 1 add 0, it's 1. Then distributive in, 2s times s is 2s squared. Add 2s times 1 is 2s. Minus s squared, distributive in, is s squared minus 4. And negative times negative, change to plus 4. Remove the parentheses, change the sign, become plus 4. Then combine like term. S squared term, 2s squared minus x squared is s squared plus 2s plus 4. And denominator is copy down, s plus 1 squared. Then next one, I'll use power rule, general power rule. So in the chain rule. So this one, this power go from and get 3, and then 2x minus 1 is the base, and 3 minus 1. And by the chain rule inside, 2x minus 1 take derivative times by 2. So this is used if the two functions are composite function. Take derivative is equal outer function take derivative. times by inner function take derivative. This we call chain rule. Chain rule. So this outer function is a use power rule. 3 go from, and base is still g of x is still 2x minus 1. That's g of x. 3 minus 1. That's use power rule. Times inner function g of x, take derivative. Inner function is 2x minus 1. Take derivative is 2. Is 2. And then time together, 2 times 3, you got 6. And then 3 minus 1 is power 2, to the power 2. And then next one also use this general power rule. And this function, the base, this is g of x to the power 5. So 5 go from, and this minus 1. And times by chain rule. By chain rule, this inner function take derivative, x squared take derivative is 2x plus 5 take derivative is 0, so it's still 2x. Then time together, 5 times 2x is 10x, and this x squared plus 5 to the power 5 minus 1, it's 4. Then next one, square root. Question 22. 3x minus 2. This is radical. This radical is square root of 3x minus 2. Means to the power 1, and the radical is 2. And change to the exponential form is 3x minus 2 to the power m over n. 1 over 2. Change to exponential form. And so this become radical form. Change to exponential form is 1 over 2. Take derivative. F prime of x equal this 1 over 2. Go to the from, and base is 3x minus 2. 1 over 2 minus 1 times by chain rule. This base 3x minus 2 take derivative is just 3. It's just 3 times by 3. So 3 times 1 over 2 is 3 over 2. 3x minus 2. 1 over 2 minus 1 is 1 over 2 minus 2 over 2. So it's negative 1 over 2. And then change back to radical form because original is a radical form. So it's a 3 over 2. This negative 1 over 2. Bring down to the denominator. Get positive 1 over 2. 3x minus 2 to the power 1 over 2. Change back to radical form. So it's 3x minus 2 parentheses to the power 1. And then here's 2. And this to the power 1 you don't write off is 3x minus 2. And this 2 don't write out is the square root of 3x minus 2. Then next one. First of all, we have to change to exponential form. So this switch up, and positive 3 change to negative 3. So the two are equal. That's original function. Take derivative. Use power rule. So f prime of x, this negative 3 go to the from times the base is 2x plus 3 to the power negative 3 minus 1, and use the chain rule. This 2x plus 3 take derivative is 2, so times by 2. And time together, negative 3 times 2 is negative 6. The base is 2x plus 3 to the power negative 3 minus 1 is negative 4. Then bring down to the denominator. Negative 6 is still on numerator. This negative 4, bring down to the denominator, become positive 4. Because this original is... we don't answer with negative exponent, so that's bring down to the denominator, use negative exponent rule. Next question, it's also first of all, this use power rule. Negative 2 go from, and the base is 3x squared plus 2x plus 1, put it in the parentheses, negative 2 minus 1, and use chain rule. This base, take derivative. 3 times 2 is 6, and 2 minus 1, x to the power 1, and 2x take derivative is 2, 1 take derivative is 0, so it becomes 6x plus 2. And then negative 2 minus 1 is negative 2, add negative 1 is negative 3. So the negative 2 and this tying together, this to the power 1, so put on numerator. Only this negative 3 exponent term, bring down to the denominator, negative 3 change to positive 3. And the base is still this. And question 25, and this is this is product. Use product rule, and first function and second function. Take derivative. First function, 2x squared. Take derivative is 2 times 2. It's 4. 2 minus 1, so x to the power 1. Times by second one, do not take derivative, is still 3 minus 4x to the power 4. Add. The first function, do not take derivative, 2x squared. Second function, take derivative. 4 go from, and base is still 3 minus 4x to the power 4 minus 1 is 3. And then 3, then base, chain by chain rule. 3 minus 4x, take derivative, is a negative 4, so times by negative 4. Then multiply out. So first one is 4x times 3 minus 4x to the power, this do not take derivative, is this. And then here, 2 times 4. 2 times 4 is 8, times negative 4 is negative 32. Those number times together, 2 times 4 is 8, times negative 4 is negative 32. Then x squared, then 3 minus 4x, 4 minus 1 is 3. Then 4x and 3 minus 4x cubed. Common factor, factor out. Greatest common factor. 4 and 32. Common factor is 4, factor out. X and x squared. Common factor is x. We x compare and x squared. 1 and 2. The lowest exponent is x to the power 1, factor out. And this 3 minus 4x to the power 4 and 3 minus 4x to the power 3 is the same base, is 3 minus 4x. 3 minus 4x. One exponent is 4, one exponent is 3. We pick up the lowest one to the power 3, factor out. Factor out. So therefore, this divided by this, 4x cancel, this divided by this, 4 minus 3, so remain 3 minus 4x. 3 minus 4x. You can distribute it in. This times distributive in. This put it into the parentheses. Put it in the parentheses. Let me write down. This one, we 4 and 32. The greatest common factor is 4. Take out. X and x squared. The 2 and pick up x to the power 1, the lowest exponent, x to the power 1. The 2 have the same base, 3 minus 4x. Compare exponent, 3 and 4. Pick up the lowest one, to the power 3. Factor out. Factor this out. Factor this out. So this term, factor this out. 4x go out. 3 minus 4x to the power 3 go out. Remain 3 minus 4x to the power 1. To the power 1. Or you can do this. It's 4x, 3 minus 4x to the power 4 divided by 4x, 3 minus 4x to the power 3. Divide. 4x cancel. And then this subtraction exponent, same base, is 3 minus 4x. And 4 minus 3 is 1 to the power 1. So this 3 out. Then you can distribute it in. It still go back this times this term, and you go back to this. They are equal, and put in this parenthesis. Now this minus, so here still minus 32. Take out 4, remain 8, because 32 divided by 4 is 8. X squared, take out x. X squared divided by x, remain x. Then 3 minus 4x to the power 3. This totally take out. So remain ax, and put this in the parentheses. You can times back in, distribute it in, you will get this. So if I do this way, it's 32x to the power 2, 3 minus 4x to the power 3. And you factor out, its greatest common factor is 4x, 3 minus 4x to the power 3. So you divide it. 4 and 32 is 8. X cancel, remain x. And these two are both are to the power 3 is same term. Cancel. Then remain 8 times x. So it's here is minus, still minus. This one, you factor out this. 32, you take out 4, remain 8. X squared, take out x, remain x. And this already take out, that's remain 1. Ax times 1 is still ax. So this term, factor out this GCF, greatest common factor, is a minus ax. Then combine like term. 4x still 4x, 3 minus 4x to the power 3. Then 3 and the minus 4x minus ax. Combine is, add together is minus 12x. And then you can factor out this common factor 3. 3 take out times by 4 is 12x. And 12x. And 3 minus 4x cubed. And this factor out 3 and become 1. 3 minus 1 is 1. Minus, still minus 12. Factor out 3. 12 divided by 3 and get 4. And here have x. So this 3 minus 12x, factor out 3. And 3 times 4. And you got 12. Then this take out 3, got 1. This take out, factor out 3, got 4x. So that's final answer. Then next one is also product rule. And this first function times second function, and you will use product rule and the power rule and the chain rule. 3 rules. Product rule is the first function take derivative. Got this. Times second function do not take derivative, copy done. Plus first function do not take derivative, x minus 1 squared, times second function take derivative. So let's see. First function take derivative, use power rule to go from the base is x minus 1 and 2 minus 1 times. By the chain rule, this base take derivative is 1. It's times by 1. And times second function do not take derivative, plus the first function do not take derivative. Second function take derivative. This take derivative by power rule first. 4 go from, and base is 2x plus 1. 4 minus 1 is to the power 3 times by the chain rule. This base take derivative 2x plus 1. Take derivative is 2 times by 2. Now then we multiply out. 2 times 1 is 2, and x minus 1. 2 minus 1 is 1, and 2x plus 1 to the power 4. Plus 4 times 2 is 8, and the x minus 1 square, and 2x plus 1, 4 minus 1 is 3. So the quick way is 2 go from is 2x minus 1 to the power 1, and x minus 1 take derivative is 1, and you got 2, and this second one do not take derivative. If you don't want to write this, it's okay. So then the second one is x minus 1 square, and this take derivative is a 4 go from, and then 4 minus 1 is 3, and then 2x plus 1 take derivative is 2, then 4 times 2 is 8, and this 3. Now compare it, the two term, greatest common factor, factor out. 2 and 8, greatest common factor is 2. X minus 1 to the power 1, x minus 1 to the power 2. Pick up the lowest one, lowest exponent, 1 and 2. Pick up 1. Compare these two have the same base, 2x plus 1 to the power 4 and 2x plus 1 to the power 3. The two have the same base. You compare exponents 3 and 4. 3 is the smaller one, lowest smaller one. So take out this, x to the power 3. And this form the GCF, greatest common factor. Factor out, greatest common factor, factor out. So which is this divided by this, 2 and 2 cancel, x minus 1 cancel, this divided by this, 4 minus 3, get to the power 1. So you got this, and put it in the parentheses. So get 2x plus 1 to the power 1, because you can distribute it in. Greatest common factor is this one, distribute it in. You go back to this. So